Let's talk about the code 106041 count sorted vowel strings. So it gives us a length n, and let's count those kind of vowel strings which are lexically sorted. So, for example, if n equals 1, we have it will return 5, a l u equals 2. There are 15 substrings, which is composed with words, for example, a e, right? And the thing is that they need to be lexically sorted. So that means we can not have EA. This is not a valid case. So, for example, A, we can, after A, we can have A, E, I, O, U, right? But after E, we cannot have A, right? So ask what's the total counts. So the thing is that this N is to 50. So apparently do the DFS or search will be TLE, right? We can use the search as some kind of um, memorizations because they are duplicates. But the thing is that for this one, iteratively, we're thinking about possibly we should go to some kind of dynamic programming approach because we can easily thinking about for every index I, right? If we end with, for example, E, A, E, I, O, U, right? How many counts, substrings from 0 to I we have, right? Then we are easy to get to I plus 1, right? I plus 1, the counts. So for example, dp I0 represent at the index I end with A, how many counts, right? So if I plus 1, well, only coming from dp I0, I plus 1, 0, right? And I plus 1 E, right? 1. Well, coming from DPI 0 and DPI 1 should sum them up, right? And and also U, right? DP I plus 1, 4, right? Will be DP0 plus DPI0 plus DPI0, 1 until I plus 4, right? So in the end, we just return dp n from 0 plus dp n1 plus dp blah blah to dp n4, right? So to do this, we can have an n multiple by 5 dp array, integer array, right? But the thing is that we'll find that this actually every state only be transit from the previous state, right? So looks like we don't need to have an ON space complexity. We can just use 5 variables dp0, dp1, right? dp2, right? So let's write code for this. We'll have, we know at the index I equals 0, right? Initially, we have a string A and a string B, a string A, string E, string I, and O, U, right? So we'll say we'll have int dp 0 equals 0, 1, right? And so that is initially it is at index 0. For this one, we should not open an extra index because it's meaningless if because at index 0, every var string has one count, right? So we have to do this dp2 equals 1, dp3 equals 1, right? dp4 equals 1. Then what we do is for int I equals 1, I smaller than n, I plus plus. Then we know, so we'll see the new dp0 will be dp0, right? And the new dp1 will be dp0 plus dp1 and also we'll say the new dp2 we can write new dp2 equals dp0 plus dp1 plus dp2, right? And also new dp3, right? New dp3 equals dp0 plus dp1 plus dp2 plus dp3 and new dp4 equals dp0 plus dp1 plus dp2 plus dp um 3 plus dp4, right? So, and then we set up, for example, after that, set a dp0 equals new dp0 and set a dp1 and enter and dp4 equals new dp4, right? But actually, the thing is that we use a new variable because we this kind of dp0, if we set it, it will change, right? If we write this, because the dp1 will change, right? But the thing is that actually we don't need to introduce the new one. We can write like this actually. We don't add dp0 plus the dp1 again. We just use um, um, dp1, right? Because this will be the new one plus this. Or we will write this should be enough. dp1 plus equal to dp0. And for this line, we didn't change, right? Then we'll have dp3 plus equal to dp2. And dp4 plus equal to dp3. So in the end, we just return dp0 plus dp1 plus dp2 plus dp3 plus dp4, right? It will be n time complexity with constant space. So Python code is very similar, dp0, dp1, dp2, dp3, dp4 equals 1, 1, 1, 1, 1. Okay. So for in range from 1 to n, so dp1 plus equal to dp0, dp2 plus equal to dp1, dp3 plus equal to dp2, dp4 plus equal to dp3, and in the end, just return dp0 plus dp1 plus dp2 plus dp3 plus dp4. Okay. So this will be our solutions.